Okay, so this is just a short demonstration of power series to kind of give you some rationale as to how they are super important and useful, especially before technology was concerned. And so my first question for you is, how many functions on this graph do you see as it is right now? And hopefully your answer is that you only see one. However, if I zoom out just a couple clicks, you might start seeing that there are actually two graphs. So this is really important and really powerful because what we call this is local linearity, or the fact that a tangent line to the graph at a certain point can really approximate the point, or I should say the outputs around that point very, very well, okay? And that's really great because around 0, if I need to figure out what the sine of 0.001 is, and I don't have a calculator and I don't want to convert that to radians and just so many things that are important about approximations, instead I can say, I bet it's about 0.001 because I can just plug into the line y equals x, okay? And I can do that approximation around 0. Now, where this interval of convergence comes into play is, well, for how good is that approximation? It's not good forever, as we can see, but it seems like there is some interval, like a circle around the origin, in which that is pretty good. Well, how do I make that approximation even better? Well, what if instead of a line, I do a cubic function? Now, I know the pattern that is created by this polynomial, so you don't need to memorize this. You might know it if you know Taylor polynomials already, but just kind of go with the big concepts of what we're trying to talk about here, okay? So in this case, you notice that when it was just a line, the interval around the origin of how well that line approximated sine was very limited. Notice that now this blue curve can approximate sine pretty good, all the way up until x equals -1 to 1. My interval of convergence is going to be a lot larger. Well, what if I then make it, should be a factorial here, no, on the bottom, x to the 5th. Oh, wow, now I am almost at, look, these maxes and mins are pretty stinking close, right, to each other. And it looks like I'm convergent all the way out to those points. Again, what if I go x to the 7th? Now, because this is both of these are odd functions, so I'm using an odd polynomial for a sine as an odd function. Notice I'm almost convergent, almost all the way out to -3 to 3. So when we do interval of convergence for these series, that's what we're finding, okay? For how good is this power series an approximator for maybe another function, okay? Or on what interval can we say that this power series is a good approximator of this other function that we might be looking at? So that's sine. I also like when we look at cosine. Now, cosine is an odd, or is an even function, excuse me. So we actually start with the line y equals 1, and technically it's x to the 0, if you will. And when you zoom in here, the interval of convergence around the 0.01 is not very big. It's very, 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 very small. But once I start adding in 1 over 2 factorial x squared, so an upside down parabola, we start seeing okay, I'm getting a little bit of a quadratic convergence on a larger interval. If I do 1 over 4, oh, no, that's not what I wanted to do. Plus 1 over 4 factorial, x to the 4th. Okay, you'll start seeing, again, our interval of convergence around that original point, around 0, 1, so centered around x equals 0, ends up being pretty stinking good. And it just so happens that if you take this all the way up to infinity, if you make this an infinite polynomial, you can actually approximate cosine on the entire real line by a polynomial. All right, let's look at maybe another function that doesn't just have evens and odds. Like let's look at e to the x. All right, so the tangent line through e to the x is going to be through the point 0, 1 with a slope of 1. So y-intercept of 1 and then a positive slope of 1x. Now again, if you were to look at interval of convergence here, not very big. But what about if I do 1 over 2 factorial x squared? Well, that looks pretty good, right? Or at least the interval is a little bit bigger. Maybe I can go from like, I don't know, like negative 0.4-ish to like 0.4. All right, well, what if I then do a cubic function? You can start seeing, oh, wow, like that is a lot better, or your interval of convergence around x equals 0 is larger as we continue to take polynomials of larger degree. Okay, and so generating these patterns is what power series are all about. You're going to be able to like be given those, or we'll maybe generate them in class, just kind of depending on what we're doing. But I love this visual and this kind of like investigation of showing you what interval of convergence really means and showing you that we can use polynomials to approximate non-polynomial functions, which is really cool and exciting.